Hello, welcome back to our ongoing series in which we are building a sample database uh, using the data model from the actual time and billing access relational database I use with my own customers. When we're finished, we will have a time and billing database. It's very similar to the one that I actually use, but I have made some changes in this sample, partly because I think I know more about what I want than I did when I built my original. And also, I wanted to show some different things to you in the process of building it that might diverge somewhat from what I did in my own personal database. Today, we're going to continue adding tables. This time, we're going to add a set of tables to handle transactions. Now, transactions are really critically important to any successful relational database. What I mean by a transaction is whenever you have interactions or activities or events that occur on a timed basis. You can identify the date and time when they occur. You can identify the participants in that event or activity. And this is a very common use for a database. I'm thinking of things, for example, here, an electronics retailer, which has a small retail location. They have a presence on the internet, Twitter account, Facebook account, all the marketing that's done online. But they also have traditionally mailed a small catalog to each of their former customers once a quarter. And this catalog offers special deals to their existing customers and so on. They also try to include new names on this mailing list every year to keep their customer list growing and then just to replace customers that drop off. So although it's primarily aimed at former customers, they will always try to include potential new customers in this mailing list. So the transaction that we're looking at here in this situation is recording the event of mailing a quarterly catalog to customers. So that's the transaction that we want to model. And the table, or actually multiple tables that we need to do that, include this primary transaction table in which we record the event itself. They always have to have a primary key. All tables in a relational database need to have a primary key. And if you want to revisit the issue of surrogate versus natural primary keys, you might want to go and look at that. I almost always use a surrogate primary key, but that's by no means the only option. A second key element of any transaction table is the date on which that transaction occurred. Now that can be a date by itself, or it can be a date and time. So if you think in terms of the kind of activity you're trying to track and capture, you may need a daily tracking, you may need an hourly, you may need down to the minute tracking, depending on the events of interest in your database. So it can be a date or a date and time. In this case, the date of the mailing is sufficient. We need at least one foreign key, and this is going to come from one of those list tables that I mentioned earlier. I call them a participating primary list table because it's a list of a particular entity, in this case, potential customers, former customers, potential customers. It's participating in this transaction, and it comes from that primary list and not from a detail list attached to that. Usually, not always, but most of the time, a transaction requires a second entity to be involved. In this case, we would talk about the catalog itself, the mailing piece that is printed and sent out. So the foreign key from that list comes from a list of all the catalogs printed over history. Of those two, quite obviously, the customer list, the primary list for the first foreign key, is actually going to be much larger than the number of catalogs, because potentially you have several thousand customers, and you would, at most would have 4 calendars a year. So 10 years, you might have 40 or 50 calendars if you do some special mailings in addition. So the relative size of the record sets in those tables is not so important as is the fact that they are both required to complete this transaction. Now, a second way in which you could include this catalog information would be, instead of having a list table listing all catalogs, you could do it as an attribute field in this table, and just populate that field with some text describing that transaction, the spring campaign, for example. And this could be a lookup or a regular text field. So it could be either the foreign key from the primary list table 2, or it could be just a text field. So these are the components that are going to go into all of our transaction tables. And around them, we're going to see additional tables that are required to complete all of the necessary attributes to track accurately what we're interested in. Now, again, in our sample database that we're building here, we're tracking work done for customers. So our transaction table is going to be built around the concept of creating a project for a customer and working on that project. We're ready to look at building our project tables. I started out here with a sample of what I call table project _SS, which stands for spreadsheet design. And this is by way of reviewing what we do not want to do in designing tables. You can see that it starts out, as I said, there's a primary key for the project. There's a foreign key to the customer table, which brings in the customer, the identification of the customer for whom this work is going to be done. We have the name of the project, building a sample database. Obviously, customer 1 is me, my own business, Overpark Consulting. The project name, again, we're building a sample database. The project description, and I'm going to zoom this so we can see the full thing without having to scroll the table too much. So the description of this project is to create a new sample database and use it to illustrate concepts of database design. Now, I originally only had just the project name, but I found that as time went on, there was often additional information about the project that I wanted to track somewhere, so I created an additional field for that purpose. Project start date, interesting artifact here. If you've already noticed, it's possible to store the date with the time or just the date. But even if we do store just the date, don't forget that the actual value in the table does include the date and time components, even though we only display it here. We are not recording a time, so it will be restored in the table as 0 hours, 0 minutes, 0 seconds. But it is always there. The start date could very well have been set up as just storing the date as well. This is partly to illustrate, yeah, this is mostly a matter of formatting at the datasheet level rather than storing in the actual table. I have a third field for when the project is complete, and an invoice code. I always use an invoice code because when I bill for the work, I want some sort of simple shorthand to kind of remind me of what this work might have been. And the invoice code helps do that. So it's GPC, which is the company and sample database. Now, that's the first step. And as you can see, I have 3 fields, all of which include the word project and date. Anytime we see a table with a repeating group like this, we know we have further normalization to do. And by normalization, remember, I'm talking about the process of converting this spreadsheet style table into one using fully relational database principles. And I'm going to scroll out here and show these 4 fields as well. And this is the same problem, repeating groups, but it has slightly different characteristics. So I'll spend a few minutes looking at these. Assigned developer. Typically working as a sole proprietor individual contractor, I only have myself to assign. But there are many cases, and there have been a number of cases, I should say, where I needed help for a particular aspect. Say, for example, I'm working on an Access project that involves automating Word, and I need someone who's an expert in Word to give me a hand with certain parts of that. So I will hire a subcontractor, and they will be assigned developer ID too. I also have contacts. I list the primary contact at the customer because I do business with lots of clients, but I need to know who specifically inside that customer is the person with whom I'm going to interact in doing the work. And I allow myself 2 contacts. Quite similar to the idea of the dates, we have repeating groups here. But even though some of them are actually called assigned developer and some are called customer contact, the reality is that these are all people. A developer is a person, a customer contact is a person. It's entirely possible, and I actually have shown that here, that the assigned developer, me, is also the contact on the customer side because I'm creating something for myself. So as I look at the data, excuse me for scrolling so wildly there. As I look at these, I realize that even though the role which these people play may be different, they're actually just people. So when I go to resolve this design into a properly normalized or correctly designed table, I really only need one table of people and then additional supporting tables or some way of recording whether that person is filling the role of a developer, whether that person is fulfilling the role of a customer contact. So let's look at that next. Here are the first tables that came out of the process of resolving the problem of the spreadsheet style table in the original project table. As you can see from the screen, I removed all of those fields from the project table that referred to attributes which could be one or more in nature. In other words, if we had 3 date fields, those are gone into their own date table. And also the associated staff or the roles that people would play were removed, and I'll show you those in a later section of either this video or the following video. By taking those fields out, I have managed this table now to where it fits my preferred look and feel for a relational table. Instead of being wide, it is now relatively narrow. We've removed all those extra fields that made it a wide table. And instead, we've moved that information down into additional narrow, tall tables. In this case, it took 3 tables to resolve that milestone issue, and I'll explain each of them in turn. Let's start with the milestone table. As you can see, I decided that in order to track all of the steps for through which a project might go, I needed to indicate the date on which it was started, the projected due date. Now this will be an estimate, obviously, the actual complete date. Then within that project, there will be work done on 1 or more days, typically several days or many days. So each time I start work, I'm going to record the date on which that work was started, when that was due, and when it was actually completed. I'm going to note that this is my first attempt here. I may revise this slightly as I go along and put actual data into my database and realize that, well, perhaps it needs to be slightly different. But this is my first attempt to capture that information. And then the third phase or stage would be when I go to invoice for that work. So corresponding to those 3 stages, I have a lookup table with project management phase, work on the project phase, and the invoice for the project phase. So these 3 stages are recorded according to the type of milestone that I'm going to consider. Again, this is now an issue not just of capturing the data accurately, but at some point we always have to ask our question, ourselves a question. Have I gone too far? Do I really need to break this out to this level? Obviously, the more complex the table structure is, the more complex the interface is going to be, so there's always that trade-off. But at this point, I think this is the data model I want to use, and I will continue with this until I get enough sample data in my actual prototype database to see if this is viable or not. Excuse me. And then the final table, here's my next transaction table. It's going to contain project ID and the milestone ID. And remember when I said a transaction table would have 2 foreign keys, one from the project, one from the milestone, and then the transaction date, or the date and time on which that action or event or activity occurred. So when I set this project up, then I said project 1, which is the sample database. We started on 3/16, which is March 16th. Remember, I'm using the US month, day, year format. And milestone 1 was the start date. I recorded at that time my anticipated completion date, my due date, would be 1 month after that. Now, again, this is an estimate. It's a way for me to keep track of whether I'm working at the right pace, whether I'm taking longer than I thought, and maybe there's something that needs to change. But it's a way to manage the project. And of course, as I start work on individual steps within this project, I will record then additional transactions. Let's say, for example, that project ID 1, and I'm going to start now at 12:15, and I'm going to say that's the work start date, which is 4, and I finished work 1 hour later, and that is the 6. So for that 1 hour, I worked on whatever work was associated with that project on that day. I think, looking at this, I may revise that, but for now, that's enough to illustrate the kind of thinking that goes into this design decision. So this feels like a good stopping place for today. Remember, we're going to continue to add additional tables as they support our goal, which is tracking all of the work done for customers on different projects. Again, this particular design may not survive. I may come back and revise it, but for now, I'm trying to account for all of the different pieces of information I need to track my work, and this is my initial step. If you like what you've seen so far, please subscribe. Come back soon as we'll move on to part 2 of adding transaction tables. Thank you.